Alright, CNT120, Chapter 3, we're on the section on IPv6 addresses. Just a reminder, remember IPv4 was developed in the 80s. We have run out of IPv4 addresses, so IPv6 was developed in the late 90s. Most people became aware of them in the early 2000s, so roughly 20 years ago. With IPv6, we have a 128-bit address. So mathematically speaking, 2 to the 128 gives us a possible IPv6 addresses of 3.4 times 10 to the 38. So in other words, 3.4 with 37 zeros behind, or 3.4, 3.4 with 27 more zeros behind. That is how many IPv6 addresses. So we have quite a few. Reminder, don't forget, binary conversions are handy for working with IPv4 addresses. Hexadecimal conversions are going to be handy when working with IPv6 addresses. Our content page has a review of both of those for you. IPv6 address has 128 bits, typically written 8 blocks of hexadecimal numbers. So here, this is a block. This is actually 16 bits because 2 hex digits is 8 bits, and 2 more would be 16 bits. So our 8 blocks here, 8 blocks times 16 gives you the 128 bits. There would be a full IPv6 address. Now, there are some shortcuts we can use for simplifying this address. If I have leading zeros in a number, let's look over here at this block 00D3, those leading zeros can be dropped. So that just minimizes. That's the same idea as if you have a paycheck of $124, if they print a paycheck where it says 0124, that doesn't affect the value. Adding a 0 on the front does not affect your paycheck at all. So in this instance as well, any leading zeros we can drop. If I have a number of blocks with all zeros in, you can use a double colon to represent that there's a series of blocks with all zeros in. So right here I have two blocks of zeros. I can do a double colon there and represent that, hey, there's zeros in here to fill in the 128 bits that we would need. So that's a shortcut way of doing that. Over here, I think we could also probably drop this down to a single 0 in here as well. I think the book example did not do that, but you could drop that down to a single 0 there. If I'm on a Linux or Apple machine, if I use the ifconfig command, I can actually see my IPv6 addressing. There it is right there. If I'm on a Windows machine, I can use ipconfig, and I can see the IPv6 addressing. So let me go to my laptop here. I'm going to do ipconfig, and I don't need anything special here. ipconfig, and I actually can see here's the IPv4 address. And right above it is my link local IPv6 address right here, out to the %9. That is actually indicating an interface, which we don't need at this point. Actually, excuse me, it's indicating kind of like our subnet mask, if you will, right here, these first 9 bits. So here is my link local IPv6 address. So that right there would be my link local. That's almost like an IPIPA IPv6 address that I have on my machine right now. There are some terminologies. They mention a link in here. This is basically LAN bounded by routers, kind of like almost like a network. That's that kind of term. Neighbors, 2 or more nodes on the same link. Dual stacked, when we have a network configured that uses both IP version 4 and IP version 6 addressing. So if I look at my network settings, let me look at my network settings on this PC right here. We'll go to network and sharing. I'm going to open up my network card. I'm using wireless right now, but I'll open up my network card. I can see that IP version 4 is configured, and I can see IP version 6 is configured. So the network supporting this would be considered dual stack. Actually, this PC is considered dual stack, and if the network is providing both to me, IP version 4 and IP version 6, then the network itself would be dual stacked. Now, you'll find that some networks are, some networks are not. Some networks are actually providing you legit IP4 and legit IP6 addresses, but some are not. That's one of the reasons we have not fully adopted IP version 6. Tunneling is a method when we need to transport IP version 6 packets across an IP version 4 network. And there's a couple of different tunneling styles that get used, but it's a way to basically pack up those IP packets, IP version 6 packets, to travel across an IP version 4 network. The interface ID, it's the last 64 bits, or basically you can think of it almost as the host bits on the IP version 6 address. So right here, if I look at an IP version 6 address, here's a global, link, local, and loopback. But if I look at roughly the first half over here, we could almost think of that as the network piece, as we were talking about IP version 4. And the remaining 64 over here is basically the host or the interface ID. That's roughly what it is. So just kind of adopting some terms we already know. And I actually put that around here to remind you. Roughly the first half is roughly network. The second half is host, if you will. If you need to kind of connect that to some stuff that we talked about with IP version 4. Down here I have a reminder the IP version 6 loopback is basically : : 1. It's all zeros with one bit of 1 at the very end. So : : 1 is essentially your loopback for IP version 6. Okay, there are a couple different IP version 6 addresses, as we just saw. We have the global address, the link local, etc. So let's go through those. Unicast, remember, specifies a single node on a network. So our global address can be routed on the internet, similar to a public IP version 4 address, and most are going to begin with 2000. And the /3 on the end indicates the first 3 bits. This is specifying the first 3 bits here. Here is our global unicast. So when we see a prefix of 2000, we know this is basically a public IP version 6 address. The local, link local unicast and unique local unicast are addresses that are similar but slightly different. So if I take a look here, the link local unicast is similar to our private IP, the PIPA, automatically privately assigned IP addressing, and IP version 4. This begins with FE80, and the /10 indicates the first 10 bits. The remaining 54 are all zeros. This link local address is it's very much like having the 169.254 in IP version 6. That's what this guy is. So this is a very local address. So if I go back and look at this right here, this is literally my link local IP version 6 address for this PC. That's what we're getting right there. The unique local unicast, this is similar to IP version 4 private addressing. We have 2 options here. We have FC00 and FD00. This would be kind of like, the private A, private B kind of thing, that kind of idea. And the /7 indicates the first 7 bits, /8 indicates the first 8 bits. So those would be right here. These are basically, you can consider them as your private addressing, if you will. The link local unicast was like a PIPA, automatically privately assigned IP, like the 169.254, FE80, and then these down here, FC00, FD00, would be kind of like private addressing. When we do, actually, if I look at my NIC right here, right now, you'll see that this is basically a PIPA type address. When we do labs labs for this chapter and on CNT125, we tend to use FD00 for any IP version 6 addressing that we do. And that would be the reason why. It's kind of like using a private address. It's standardly accepted that that's an address to use. There is the loopback address, similar to an IP version 4 loopback. Consists of 127 zeros followed by a single 1. So right here, : 1. If I were to ping : 1. Actually, I need a ping /6 : 1. That's your ping command for IP version 6 on a Windows machine. Ping /6. If I ping /6 : 1, that's essentially pinging my IP version 6 loopback. And again, just like pinging loopback on IP4, it's checking to see, is TCP/IP version 6 installed? Is it functioning? Is my NIC recognizing that? Again, kind of like reaching out my door and hitting my own doorbell. That is my loopback for IP version 6. There is also a multicast address for IP version 6. Some of our routing protocols we deal with, and again, multimedia type things, might be using a multicast address. This is going to begin with FF00, FF00, and if you look here, it's kind of like broadcasting, with the 255 kind of deal. It's that kind of concept. But with IP version 6, FF is the beginning. That is your multicast address. And that was this guy right down here, FF00. So these prefixes start, there's meaning in these prefixes very much like the first octet in IP version 4. There's meaning in those prefixes very much like the first octet in IP version 4. There is such a thing as an Anycast address for IP version 6. So this is a way to identify multiple destinations that it's trying to communicate with, a way to maybe find the closest DNS server. So it's kind of like, hey, anybody out there can respond to me? And the reason this is used is because IP version 6 does not do broadcasts. IP version 6 is not going to broadcast. So the Anycast has kind of taken that place. The book uses this picture to kind of try to show you the idea here. IP version 4 uses broadcast, IP version 6 does not. That was a way to send a message to everybody. Multicasting was a way to send to a small portion of, in most of our cases, like all the routers, if you will. Anycast gets used in IP version 6. IP version 4 did not have Anycast. This is a way to find maybe the closest DNS server. And then obviously Unicast is go to a specific node. So there is a couple different IP version 6 communications as well as your IP version 6 prefixes. IP version 6 also does a auto configure. It can actually build its own link local IP address using stateless address auto configuration. Again, similar to a PIPA in IP version 4. The result, however, though, is an address on a computer that you can continue to use on the network. There's a couple steps that it does to do this. The first step, it's going to create its own IP version 6 address. So it's going to use the FE80 prefix. And that'll handle the first 64 bits. The remaining 64 either randomly generates or it generates using a portion of the MAC address, the unique portion of the MAC address. It then checks to see if the address is unique on the network. And if it is, then it actually asks the router, hey, can I use this and can I get any more information from you, like gateway and that sort of thing. So I have here, I think I have 2 examples here. Yes, I do. Here is from, I think this is actually from my laptop or one of the lab machines. Here's a randomly generated IP version 6 address. Here's the MAC address of it, and the ending is F5F5CA1. If I look at the actual IP version 6 address, I'll see it does not end with that. So this was a randomly generated IP version 6 address that it would check on the network as anybody using this. If they're not, this will be my IP version 6 address. Meanwhile, I think this was from one of my Macs that I had once upon a time. Here is the generated from the MAC address. So if I actually look at the MAC address on this thing, it ends with 0D6B24. And if I look at the IP version 6 address, it ends with 0D64 or 6B24. So this is actually using the tail end of the MAC address, the unique part of the MAC address, to build the IP version 6 address. When we do IP version 6 addresses in LabRoom, we tend to go this way. We tend to do it this way, that way we have control of what's going on, and we're sure to hopefully not be duplicating any IP addresses. So there is IP version 6.